Okay, in this video we're going to go over the substitution method. Okay, all right, let's say we want to solve for x and y using the substitution method with these two equations. Okay, now what we're going to do is I like to take the more simple equation of the two. Okay, so in this case it would be this top equation, the x plus y, and I like to solve for either x or y, and then after that we're going to substitute in either the x or y for one of these x or y's. Okay, that sounds a little like a mouthful of words. Okay, so let's start off with what I said. Let's start with this equation since it looks less complicated, and let's solve for either x or y. Now, in your book, you're going to see it's going to be set up like this, vertically. Now, what I like to do is I actually like to separate these two equations horizontally. Okay, so I'm going to rewrite them so they are written horizontally like this. X plus y equals 9. Okay, so I'm going to put one equation over here on this side. I'm going to put the other one over here. 2x plus 3y equals 20. Okay, so I'm going back to this. I'm going to solve for either x or y. You can choose, it doesn't really matter. Okay, so in this case, I'm going to solve for x. Okay, so that means I need to get rid of this plus y by subtracting y on both sides. Okay, so now I'm left with x equals 9 minus y. Okay, now what I'm going to do is, since I have x isolated, I'm going to substitute this x, since we have the x here, with 9 minus y. I'm going to like plug it in. So now this becomes 2 times, remember 2 times x, but remember our x we just figured out was 9 minus y. Plug that in. And then bring everything else down. Okay. All right, so this looks like distributive property. So that's 18 minus 2y. Okay, now I'm going to bring down everything else. Plus 3y equals 20. Okay, combine like terms. Okay, so I'm going to bring down the 18. So negative 2y plus 3y equals 1y. So just y equals 20. Okay, now I want to get rid of the 18 because I want to get y by itself. Minus 18. Okay, now I know that y equals 2. Okay, so we know y equals 2, but we have to figure out what is x. Okay, well now that we know that y equals 2, I can plug it in over here. Okay, so x equals 9 minus y, but we just figured out what y was, so let's put that 2 in there. So x equals 9 minus 2, which equals 7. So our x equals 7. So our solution is 7, 2. Okay, let's do another one. Okay, let's do this one. Okay, in your book it's going to be written vertically, but we're going to write it horizontally. 2x minus 6y equals 8. Okay, and then this one's x minus 3y equals 10. Okay. Okay, so let's choose the one that looks a little bit less complicated. I'm going to pick this one just because this one doesn't have a coefficient, and I figure it could, might be a little easier in this case. Okay, so I'm going to solve for x since it's already isolated. So I want to get x, or I want to isolate x, and I got to get rid of this minus 3y by adding 3y on both sides. Okay, so x equals 10 plus 3y. Now we're going to substitute. So we're going to go over to this equation. 2 times x here's x, okay, 2 times 10 plus 3y. 2 times 10 plus 3y, okay, bring everything else down, minus 6y equals 8. Okay, this is distributive property. Okay, so that's 20 plus 6y minus 6y equals 8. Okay, now we can combine like terms. 6y minus 6y, well, that's 0. So that cancels, they cancel each other out. Now we're left with 20 equals 8. That's not true. So this is a false statement. If it's false, okay, so it's false statement. Okay, if that's the case, then that means that this system has no solution.